Welcome to Augustus 3 and 4. Kevin McNamee is the director of Hindsight Security Labs, which is now part of Alcatel-Lucent. Kevin's presentation is titled, How to Build a SpyPhone. If you have any questions, please reserve those till the end so we know that we have enough time to go through the whole presentation. And with that, Kevin, all yours.
Hi there. It's nice to be here today. So basically I'm going to be talking about how to build a SpyPhone. But more specifically, I guess the key thing that will be of interest to the audience here is how I can take that SpyPhone module and put it into just about any Android application I want to. So in other words, that's sort of, there'll be three parts to the talk. I'm going to talk a bit about first of all, a demo of the SpyPhone in action. And then I'm going to talk a little bit about the SpyPhone design. And it's been specifically designed, as I said, so it can be injected into an application. So that's the last part of the presentation. I'll show you how that's done. Then we'll take some questions and conclude the talk. Anyway, so just to get, by way of getting started, this was the SpyPhone back in the day. Obviously, well actually this is a SpyPhone that the spies would use. The SpyPhone I'm going to talk about is a SpyPhone that you could use to spy on other people. So SpyPhone of today looks a little bit more like this. I'm going to use just a regular Android phone. And I picked Android. Android is a very flexible platform to work with. It's very open and it's sort of very easy to sort of do these types of things with. So that's the SpyPhone today. So we're going to be looking at Android specifically. I believe the same type of thing can be done with iOS and other phone operating systems, but we're going to focus on Android. Back in the day, you used to do surveillance. You needed all this various pieces of equipment. You'd need to sort of tap the phones. You'd have trucks with all sorts of electronic gear in them. And today, all you need is basically just an Android phone. You take an Android phone with some specially designed software on it. You can track the person who owns the phone. You can basically monitor their phone calls. You can monitor their location. You can basically take control of the phone. You can send messages from that person's phone. You can look at the contact list, etc., etc. It is a very powerful sort of cyber surveillance device, the phone. If you've got someone's phone infected with this type of spyware and they bring it to work, to the office, you can track them at the office, you can monitor meetings, you can do all sorts of things like that. So it really is a very, very powerful surveillance platform. And the command and control for this is all done through the internet. So there's no special extra equipment. They basically, within the phone, when it's got something interesting to say, it checks in through the internet to the command and control site, and you can, that's where it's controlled from. And I'll show you a demo of that shortly. Now, countermeasures. This was the countermeasures in the old days, the cone of silence. So if you had if you were someone was spying on you, you could always go into the cone of silence and things would be quite safe. Countermeasures today can be a little bit different. And that's where the company I work for comes in. We've got technology we can put in the network to detect this type of command and control traffic and remediate the issue. So basically that's why we created this SpyPhone module. Because we take this, we use this as a demonstration when we go to our customers, which are basically service providers, mobile service providers and internet service providers. And we use this as a demonstration, this SpyPhone demonstration, as a vehicle for basically making people aware that there is a huge issue in the mobile network with malware. It's still early days, but it's very, the potential is there, and so we use this as a demonstration to basically educate our customers on the dangers of what's out there. And then of course, the second part of that is we then demonstrate our product and stuff, and you won't see that today, just purely the technical aspects of how the SpyPhone works and what it does. A smartphone is a very powerful device. It's got access to your location, the internet. It's quite powerful. It makes the perfect platform for sort of spying. I would say, basically sum up, it's a perfect cyber espionage tool. It can be used to track the victim's location, download his personal information. It can intercept and send messages. I can record the conversations. Okay? I can do all of that. So enough said about that. I think what I'd like to do now is get straight to the demo. So I'm going to shut down the presentation here. And on this side here, we've got this is the SpyPhone, and this actually it's on the table. I've just got a screenshot. This is the phone I'm going to use. And on the right-hand side here, we've got the command and control console that the person who's tracking the phone would use. So what we've done is we've taken the malware, the SpyPhone module, injected it into a copy of the very popular Angry Birds game, okay? And then we send an email to the guy saying, look, you've got to go download this game. It's really cool. You have to play it. And so that's what the person would do. We can also post this game, this infected game, at third-party websites and places like that. We can do that too. So let me just go to the browser now. And so when the guy gets the email, he clicks on the link, it takes him to this really fairly realistic looking app store where they get to download the malware, the game. And we decided to call this one Very Angry Birds because it's got the SpyPhone stuff in it. So we've got it sort of there. So what the user would do is he then goes and he wants to download the game. And that's what we're going to do now. We download the game. On an Android phone, when you install an application, it gives you a list of all the permissions that the application needs to operate. And that's what it's doing here. You see a whole list of permissions. The person who's going through this, what they want to do is they want to install the game. Every time they install an application, it gives them a big list of permissions, but they want to install the game. So what do? They press the install button. Because they see these permissions all the time, they really don't pay much attention to what they are. So the game is being installed. And then the next thing they want to do is start the application. So we start the application. And this is going to bring up a legitimate. Now you notice over here, you see this line popped up? That's it now checked in with the command and control site. And you can sort of hear the game. I'll shut that off because it's very annoying. So notice that the game is the game the way the user would see it. There's no evidence whatsoever that there's anything unusual going on here. They play the game, everything's all really cool. Even when they stop the game, the SpyPhone service, which is running in the background, continues to run. And even if they reboot the phone, the SpyPhone service will be restarted. It's got a permanent presence now in this device. Okay? So the device is infected with the cyber espionage SpyPhone software. And it shows up here in the console. Okay, and so the first thing I'll do is I'll have a look at this and let's find out where the device is. So we'll locate the device and we find out here it is in Las Vegas. Okay, now let me emphasize the communication here is not going on between the phone and this computer. The communication is going on across the internet to a web server in Ottawa, which is where I work. Okay. The only reason I've got the thing tethered to the PC is so you can see the screenshot. Okay. We also have some other phones in here at the same time. We got this one here, I believe, and that's one of our sites in China. So you can have an international network of SpyPhones monitoring them all the time as you go forth. So it's kind of neat. I don't want to interrupt these people. They're probably doing a demo over there, so I'll shut that one down. And we'll focus on the one that we're dealing with here. Now, what you'll notice is over here we've got information that's from telling who the owner of the phone is. We've got his email address, his phone number, and the subscriber identifier from the phone and the device ID of the phone. All the information from the phone has been downloaded to the command and control site. It's available right there. We can also track the location 24/7. And that's basically all the features of the phone provide this. The other thing we do in this sort of SpyPhone context is we download the contact list for that particular person. This gives us a list of potential other targets that we might want to go after. If we were using this in a sort of industrial cyber espionage type of scenario, we would like to find out who this person talks to, who's their contacts, who they deal with. And then we could use these, we could target these individuals also for the same type of attack, okay? So you could imagine when you start off, you just basically spread this game around some of the app stores, hope people download it, and then focus in on when you find someone from the company you're going after, you then can focus in on their contact list, who they talk to, whatever. Some of the other things we can do is we can actually update the software. I won't bother doing that here. We can download a new version of the SpyPhone onto the phone. We can send messages to the phone. So for example, you know, if you wanted to use this for other purposes like scaring people, you could actually have messages pop up. I think if oops. I think someone's calling my phone there. So the other thing we can do is we can access the SMS messages in the phone, the email, locate the phone you've seen. One thing we can do is we can activate the camera on the phone. I'll see if I can sort of do this right now. So we'll take the camera and we click the peep function. This takes a little bit of time because it has to actually take a picture and then send it down to the site, the command and control site. So the command is still currently running. It should now have finished because it's changed from command pending to clear. And let's see what we've got over here. So we should have an image show up here fairly soon. There's me, took a picture in the front, and we also took a picture of you guys in the back. So we can do that. So remotely I can take pictures. You also noticed if you looked at the screen of the game's still going on. The person didn't know that there was any picture taken. It's done in the background without the user knowing. We can use the same type of technology to take videos, okay? All on the phone. The final thing I'd like to do, and as part of the demonstration part, is to use the listen function to actually record some stuff from the phone, so I'll try that now. This is the part of the demo that gets a little bit sketchy because it's sort of, we'll see if it works. This is a test, 1, 2, 3. This is a test, 1, 2, 3. This is a test, 1, 2, 3. This is a test. So I'm going to click here for the audio. Just connecting, it takes a little bit. It's hard to hear. Let me just.
This is a test. 1, 2, 3. This is a test. This is a test. 1, 2, 3.
Did you guys hear that through this mic? Okay. So I should have probably told them I wanted to play that sound. I'm sure that the tech guys could have arranged for me to have a microphone. But you can hear it. So I recorded the conversation, downloaded it at the command and control website. It's all pretty cool. So that demonstration is just to show you the capability, the types of things that this SpyPhone technology can do. Okay? So what I'm going to do now is move on and talk a little bit about how we designed the technology and why we made some of those design decisions. And for that, I'm going to go back to the presentation. Okay. Okay. Now the first design decision we made, well, first of all, let me sort of give you the background on how we did this. We put this together. Originally, we wanted to have sort of a SpyPhone remote access Trojan type of thing that worked with an Android phone. So we took a demo application called Searchable Dictionary, and we actually modified that to put the SpyPhone software module in there, and we implemented it as a service. And a little bit later on, we said, that's really cool, but wouldn't it be better if we could take that and then inject it into any other application? So that was our second phase. So you'll see some stuff in here that was from our original design, which was just basically embedded in an application that sort of basically as a programmer would using Java. But here's a little bit of information on how the implementation works. First of all, we implemented it as a service on the Android phone. That means it's a self-contained component that runs in the background. It can be started at boot up, and a service, is we've discovered later, is something you can easily just attach onto another application and have it work just fine. And it doesn't even disturb the operation of the rest of that application. Okay, so that was sort of the design decisions there. Self-contained component, can run in the background, doesn't interfere with the execution of the app, and it can be started at boot up. Okay? For the command and control you've seen there, basically it's just a sort of an HTTP command and control using a Node.js web server. We've got certain commands. It's just basically a sort of a JSON interface that's going back and forth. So there's nothing magical about that. And that was very easy to program in at the Android they provided. The Android SDK is fairly powerful and very complete. It provides interfaces to do just about anything you want. So there was a very low learning curve to do this. When we did this, we'd never actually done any Android programming per se, and we got this thing up and functioning within a couple of weeks. Okay. Here's a little bit of a diagram showing how original design. We have the searchable dictionary application that we built using Java code, and the Java code's over here. And we basically put it in this example Android Droid Whisper. So that's our piece that we added. And that's the piece we're going to cut and paste into the other applications later on. Okay? Now, we're not taking advantage of any specific exploits or vulnerabilities here. We're using the standard APIs that Android provides. For user information that we get from the phone, we use the account manager classes. For phone and SMS, there's an SMS manager, a telephony manager. We can use that to intercept calls, to send and monitor SMS. It's all there. The location, again, there's beautiful classes to handle the location of where the phone is. For recording media, there's an excellent media recording thing which we use to do the recording of the audio, and also can be used to record video if that's the case. Now some people may say, well, if you're trying to record video on the phone or take pictures, the guy's, if it's in his pocket, it's not going to be very good, right? So you want to, let's say for example you wanted to get a good picture, you can send the guy a text message, because you know his phone number, right? And what do you do when you get a text message? You hold your phone like that. Then you can take the picture. And then you can send him a call and you hold him up like that, and then you take the picture out this way. So you can actually get people to, trick them into having pictures taken and stuff like that. Getting the camera to work without the user knowing was a little tricky. And you notice there's a whole bunch of classes we use in here. For example, they've got the audio manager and the surface holder and stuff like that. We had to turn off the audio temporarily so you didn't hear any clicking sound. And there's also a video, a video preview that goes up, and that you can't turn off. It's there. But what we did is we told the system to show it in 1 pixel. Okay, so if you show the whole video preview in 1 pixel, it's hard to notice. So that was some of the tricks of the trade we used there. As I said before, the web command and control, it's all there. All the pieces you need to build it are all there. Now, one of the things we did leverage some of the weaknesses in the Android security model. Specifically, these applications have to be signed. So what we do is we sign it with just any old certificate that's needed. And as it turns out, that's not a major issue, because the certificates, so they're checked to see if the application has one. They're not really actually, any old certificate will do. A self-signed, doesn't matter who it belongs to. I'll talk a little bit more about that later on. Okay, so that's just some of the design stuff that we chose to build the app. It's a service. What I'm going to do now is I'm going to take you through the injection process. How do we take this and put it into an application? Okay, and for that I'm going to shut down the service. I'll put these guys away for a moment. And there's a couple of things I'm going to bring up over here. It's a little cheat sheet for me because I can never remember these things as I'm going along. And, okay. So the first thing we have to do is we chose Angry Birds. And we chose Angry Birds not because it's got any, it's a really nice game. It's very popular. And there's nothing special about you choosing Angry Birds for this demonstration, just because it's a pretty good game to use. And we can do the same thing to any Android application, it doesn't really matter. So the first thing we have to do is get a copy of the APK file. The APK file is basically a zip file that contains all the components of the application that you're dealing with. Okay? And inside the application file, there's basically some Java bytecode. Actually, it's Dalvik bytecode. It's not really Java. They use Dalvik, which is a different flavor of Java. And there's a file in there called classes.dex, which contains all the bytecode. And you can try and replace that, and there's another I believe there's another talk at the conference when they talk about the master key vulnerability, and that's they actually replace that file to get in. We use a different technique. What we're going to do is we're going to open up that entire APK file into its component parts, disassemble it. Okay, so we're going to basically get a list of all the little assembly components in a funny little language called Smally. And then what we're going to do is we're going to copy our stuff in there to that directory structure and then rebuild the app. Okay? So the first thing we want to do is we want to take the application apart. Let me just show you what I got here. Trying to remember where my... Okay. So in this directory here, which is inject, I've got a number of things. First of all, I've got a copy of my searchable dictionary thing. That was the original application that we worked on, and we put our SpyPhone module in there. So searchable dictionary contains our SpyPhone module. Angrybirds.apk is a version of Angry Birds we downloaded from Google Play. We went out to Google Play, we downloaded the Angry Birds app, and we got a copy of it. The other things in here you don't really have to worry about. The keys is our signing keys. The hello APK and the searchable dictionary, don't worry about them for the moment. Okay? So the first thing we do is we want to open up the Angry Birds app. Okay? APK tool. And we want to disassemble. So APK tool is for managing APK files. It takes them apart and puts them together. We want to disassemble Angry Birds. Whoops, hang on. Let me just back up here. Inject. APK tool. I'm a very slow typer, bear with me. Disassemble Angry Birds. Okay? And what it does is now going to start taking this apart. You know, it's created now a directory called Angry Birds, and it's going to put all the components from the application in there. Right? This is a demo, so we have to wait until it does that. It takes a little bit of time. And it's almost finished now. There we go, all done. So what I'm going to do now is open up the Angry Birds whoops. So the first thing you know is we've got a number of directories. There's assets. Assets are things that it requires, like sounds and stuff like that. So are resources. There's some libraries in there. But the key thing is this Smally code. That's where all the bytecode in an assembly language format is located. And that's what we're going to be working with. The other thing we have in here is the manifest. And we're also going to be modifying the manifest because that's the thing that tells it what services are in there, what permissions it requires, and so on and so forth. So that's all in there. So I think the first thing we'll do is we'll start with the actual code itself. So we'll start with the Smally code. If you look at Angry Birds, it's got all of these components arranged in sort of subdirectories. I don't even know what any of these things really do, and I don't have to know that to do what I'm about to do. Okay? What I'm about to do is I want to copy Droid Whisperer into here. Okay? Now, follow me this is very technical here. I click on the copy, and then I click on the paste. Did you all catch that? Thank you. Okay, so that's the code copied. It's done. There's a couple of other things I have to do, and this is where I'll go back and use my cheat sheet. So we've done that. Yeah. So we'll work on the manifest next. When you go in the manifest, there's some things you want to learn from the manifest. The first thing is you want to find out what's the name of the application. This is its name here because we're going to use that later on because we have to add that, you put that in certain places in the code. The other thing is we want to define a service. And finally, we want to define the permissions that we're going to use. So I'm going to go into and this is in the Angry Birds app here. And we go into the manifest. Whoops. And I'm going to take the manifest and drag it into Notepad here. And then the very first thing I want to do is, just before the application here, we're going to define our service. And that's the part I need here, so I'm going to cut that out. And so what we're doing here is we're telling it in the manifest that there's going to be a service that you're going to run when you start off that's available in this, and it's called this Droid Whisper Dictionary Service. And it's going to belong in part of the application called ComRovio KA3D. That's why you need that name part from the manifest too, because that obviously varies depending on the app you're injecting it into. The next thing I want is my permissions. And there is a paper that goes along with this that contains all of this information in it. So what we're copying and pasting in it describes that. So you don't have to take really close notes here. So I'll go in and put the permissions in. So that's that done. Final thing, basically, just let's save that. So the manifest has now been modified to include the permissions I need to define the service that's going to be started. It's all pretty cool. And I save that away. The next thing I'm going to do is I'm going to actually, within an Android application, you can define services, but something has to start the service. So I have to go into the Angry Birds code, and I have to put some code in there to start my service. That seems to make sense. So first of all, I find out where the main application is in Angry Birds. And it turns out that it's in here. And that, again, that KA3D you see there, that comes from the manifest. That tells me where to look. And I go into the app, and I'll drag this again just straight over to Notepad. This, by the way, is Smalley code. It's sort of like an assembly language version of the Dalvik bytecode that we're using. And the very first thing that happens in an Android application is the onCreate function is called. So I want to find that. So let me just go in and we'll find onCreate. Find next. Whoops. Where is it? There we go. Okay. And you have to know a little bit about how Android apps work, and have a little bit of knowledge about this bytecode. After the onCreate, this is the onCreate function here. The onCreate function generally calls it the super class. And it's just after that. So it's right here is where I want to put in my code to invoke the service. And so I'll go back to my cheat sheet, because I have a list of this is the Smalley assembly code that I want to copy in there to create that. Just stick that in there. So that's that. And now, how did I know this is the code I needed to put in there? I simply copied it from the original application that I wrote. There's good documentation in Smalley. You can learn the whole thing, but you don't have to know much about it to do this type of stuff. I believe there's just recently been announced this sort of binder kits you can get that will allow you to do this automatically. And there was some news a couple of weeks ago about binders for Android that would take something like a service and inject it into an existing application. So that's all I'm really doing here in a very manual process. So what we do in here is, as soon as the onCreate function is called, we then activate the service. And that's what we're doing here. Basically, it's calling the function to start service. Okay? And we don't forget, we have to save the file away. So that's a lot of the real technical stuff out of the way. Now I have to rebuild the app. So I go back to my APK tool. What I want to do is I want to build. And I'm going to build from the directory, Angry Birds, and I'm going to put it in something called birds. .apk. Okay? So there we go. And it checks to see what's going on, and it's remember before it was back smalleying, now it's smalleying all the stuff together. And away we go. So it's rebuilding the application with all those changes I put into it. And it's putting into a file called birds.apk. Now, if I try and run this install this birds.apk on an Android phone, it's going to complain that it's not signed. So I have to sign it. And for that, I basically go out and I create a self-signed digital certificate with the appropriate private public keys. And I save that away someplace. And that's where I've saved it in my, if I go back here to the inject function, let's go here, inject. That's in this keys file. So it's simply a certificate I created for myself. And I go back in now, and I use this powerful and concise command, jar signer. I'll cut and paste this rather than save you the trouble of watching me type it all in. So what this is doing is it's going to sign the file birds.apk with my keys. And it's fairly straightforward how it does that. Off it goes. Oh yeah, I need the passphrase. Put in the passphrase. And it goes out and it signs all the components with that digital key. And I can take this now, and I can take this and I can put it on an app store, I can put it in Google Play, I can put it anywhere, and it's going to be happy, the fact that it's got that's been signed by those keys. There's no, as far as I can tell, there's no user interface on the phone that's going to tell the user who signed anything. As long as it's signed, it gets installed. Nobody even says who signed it anytime. It's really quite amazing. Okay. So, the next thing we have to do is, I'm not sure why we have to do this, but I just do it because it's in the instructions that come with the Android SDK. And we do this zip align. I'm going to copy it to this other file here. So that's it. Now that's the whole task and finished. I can now take this and put it out there. So just to summarize, that's a version of Angry Birds that looks exactly like the game, and it functions exactly like the game, except it's got my code, it's got that spyware code that you saw demoed inside it. Nobody can tell the difference. Now, just in terms of the signing stuff, let me just go through and make a little bit here. Just to show you. So I can go through and you can look at the digital signature I signed it with. This will just flash off the screen. So you can see it's been signed by Kevin McNamee of Kindsight. And it's been, whatever. If I actually, one of the interesting things is if I go back and I look at the original application. Let's say angry. Whoops. It's signed by Rovio, of course, which is the company that makes Angry Birds. But look at the dates. Oops. The date range. This certificate that they signed it with originally, it is created. It's valid from August the 19th, 2010, until July 26th, 2010, and this gets installed on the Android phone with no questions asked. So even if your digital certificate is filled with rubbish, it still gets installed. Nobody's actually checking it. And I think that's one of the things that I think is a serious flaw in the Android security model, is the fact that there is not really any rigorous checking done in these digital certificates that are used. It's possible they're signed, so why not take advantage of the signatures, verify who it is, enforce something like somebody has to register at least to get a digital certificate they can use. That would really help solve this type of issue. So that's basically the how to inject the malware into the app. So I'm going to go back to the presentation now and bring this back up and go down. Okay, so this is just to sort of go through the app signing thing again. All apps must be signed. Any old signature will do, self-signed. Okay, it's only checked at install time. That's another thing I did, is I can take an APK file on the phone, and if I can change the APK file on the phone, I need write access to do that. I can do that, and the system will not complain about the digital certificate being overwritten. So that's a pretty big flaw there too. Now, granted, in order to change the APK file on the phone, you basically have to write access to the directories where the APK files are stored, which requires that you've probably had to jailbreak the phone anyway, so it's not such a huge, big deal. But it's still a flaw. The other thing I find concerning is the fact there's no user interface to view who signed the application. There should be. When you install an application, it should at least say that this was signed by Kevin McNamee from Kindsight. Or if there should be something to let me find that out. Now, there is some things they did do. If I wanted to replace an application on the phone, the signatures have to match. Okay? So I couldn't replace an existing version of Angry Birds unless I changed the name. Okay? So if I change the name, I can replace. I'm not replacing it. I'm just putting a new application on there. From the Android developer site, this is what they say. The certificate does not need to be signed by a certificate authority. It's perfectly allowable. Typical Android applications use self-signed certificates. So that's what they say about that there. Okay, I'm going to sort of wrap up fairly soon here, and then open the floor for any questions. One of the things is that there is there's a whole little cottage industry of spyware that you can buy for phones. And it's typically aimed at the consumer market, and it's typically aimed at tracking your loved ones, or tracking your children, or tracking your business partner, or whatever. A lot of times they started out pretty shady, like tracking your cheating spouse and stuff like that. But now they tend to be transforming into this track your children, make sure they're safe, which is a very legitimate type of thing to do. But I think the capabilities of these SpyPhone applications, when you take that and apply it to this bring your own device type of thing, and also when you add in the fact that you can take the functionality and secretly put it inside any application you want without the user really knowing. I think when you put those together, you've created that sort of like perfect storm of, given the ability to sort of take over someone's phone, track them, and actually use it for industrial espionage. Now, the other thing is if you look at these devices in terms of like the advanced persistent threat area, right? This phone, okay, it's a perfectly fully functional network device. So if I bring this to work and I connect onto the Wi-Fi at work, I can put software in that phone that's going to scan the network for vulnerabilities. It's going to be able to download, as this one can do, download an updated version of itself. It can take information it's learned and send it to a command and control site. So in terms of an advanced persistent threat platform, there's a huge opportunity here for that type of attack. The fact that someone's just walking around the building with their, the phone that's capable of scanning the network, and it can launch attacks from the inside out. Also, the interesting thing is oftentimes, like when, of course, in a network, you protect it with firewalls, et cetera, et cetera, et cetera, but this has got an internet connection through the air out to wherever it wants to go. There's no firewall between this and anywhere, okay? So basically, it's a backdoor into the network. And this type of, if you think, we're talking SpyPhone here, because SpyPhone's a pretty cool word, but effectively what this is, it's a remote access Trojan that we have in this phone. And, I think it's sort of pretty scary. So I think that's basically what I've came here to say today. And now I'll get time to take any questions. Okay. Thank you very much.
Does
Yes.
the service do anything to obfuscate its presence, or can the user look up a list of this started service?
Okay. The question is does this particular application try and obfuscate its presence? The answer is no, it doesn't. So if you do look at services that are running, you will be able to see it in there. I think you could go to measures to obscure it by making it less obvious in terms of names and stuff like that. But this is a proof of concept type of thing we put together. Yeah.
What happened with the antivirus?
Antivirus will currently not detect this one because it doesn't know. It's possible for antivirus to detect stuff like this, but there are obfuscation, code obfuscation techniques that we can use. So if I was putting this in, I could basically obfuscate the code and then inject it into an app, and I can keep repeating that, and that process can be automated. Yeah?
So what are countermeasures?
Countermeasures, well, I think countermeasures have antivirus. I mean, have antivirus, because if there's any known infected apps out there, you have them. But what we're looking at is detecting the command and control traffic in the network itself. So in terms of obfuscating code, that's easy to automate. It's very difficult to change a command and control protocol on the fly. You have to change the server end, you have to change the clients and stuff like that. So that's what we would recommend doing, is that combination of on the device malware detection, traditional antivirus, combined with network detection to look for the command and control. Yeah?
So why is it that you have to change the name of the application? Can't you just sign it again, the original?
Oh no, in this case we did just sign the original. We did that. Okay.
That you have to change the name, otherwise it don't work.
If I wanted to, okay. So in this demo here, what I did was I basically took the application, just signed it. If you're installing that application for the first time, there's no problem. If a user already has a copy of that application installed on the phone with the same application name, it does check the signature and it will say the signatures don't match. Okay, so that's the only case. And in that case, I can get around that by just changing the name. Okay? Yes? Yes, it is. I mean, the command and control can communicate with the full function, the whole Android APIs. Any API we can use, we can leverage that to do whatever. We can drop binaries onto this phone. We could get root access remotely through this type of application, like Loda. The possibilities are wide open. Yes?
Is it fair to say that it's easier to develop and deploy these type of exploits on an Android than on an iOS? Is that fair to say?
The same functionality is available in both platforms, but I think that the iOS has a stronger control over how to get an application in the field. You have to get a certificate from them that identifies you, so I would have to sign up and get my certificate, so I'd have to sign it with mine, right? And then they also vet the code before it goes up in their app store, whereas the Google App Store does it after. So you put it up and then they check it, whereas the iOS, they check it and then put it up. Okay? Yes? Google Play will, I'm not familiar with the details of it, but I'm sure if this got a particularly bad reputation, they would detect various flavors of it and boot it out of their app store. But there's still the third-party app stores you can put this stuff in. Part of the sort of the phishing attack that led to this is we actually bring the guy to one of those third-party sites to download the app anyway. We spear phish the guy. Over here? Okay. Yeah. The thing is that all the functions in here look like a regular app. I mean, there's nothing illegal we're doing. So we just build it, sign it, send it out. If somebody declared that antivirus could be written to detect this, they could look for our service name, for example. Look for Droid Whisperer, and we'll chuck it out of the thing, right? That would work. Yeah. I can't hear.
In most of the Android phones, there's a setting in the developer options to allow applications that are unsigned. You have that turned on, or not unsigned, but untrusted.
This has got this is allows you to. It's turned on. I can download from third-party sites. That's correct. But however, our phishing attack would provide the detailed instructions on how to make sure that that's turned. Look, this is a really good game and it's free. You can't get this on Google Play, so you have to turn this thing on. And here's the here's how to do it. You know, I mean, it's fairly straightforward. Yes.
How do you solve the situation issue when you're on a Wi-Fi network to communicate over the cellular network rather than through the Wi-Fi network so that your command and control functions can't be destroyed via Wi-Fi?
We haven't done anything at that level. We just use whatever network connections available. However, that's a possibility. You can, through the APIs, determine where you're connected and make those decisions. We haven't done that here. No.
Any more questions? Thank you, Kevin.
Thank you.